Hello friends, so today we are going to see oscillators using operational amplifier. So far we have seen amplifier in which negative feedback is used, but in case of oscillator we are going to use positive feedback, and especially we are talking today about the operational amplifier using that is oscillator using operational amplifier. So see, we know what is feedback, that it is a process of injecting a fraction of output of a device back to the input is known as feedback. As we saw, this is an operational amplifier and here there are inputs. So this is inverting and non-inverting terminal, and when it gives output, some part of the output through feedback it is given to the input, or we can say here in general this is a system in which this is an input and this is an output. So if we take some part of the output through feedback network, it is injected in the input, that is called as a feedback. So here it is feedback network or feedback circuit. So see, in amplifier the feedback has been found very useful in reducing the noise. When we use feedback in amplifier, it reduces the noise and making amplifier action stable. So it also stabilizes the gain of an amplifier. So that is a case of amplifier, but feedback aids or opposes the input. Now here you see, whenever we are giving feedback to the input, so here it is input, this is output. So whenever part of output is given to the input, so the question is, suppose this is input I and this feedback IF. So when IF is added into I, that is in input, so effective input increases or decreases. On that basis we can say, depending upon whether the feedback energy aids or opposes the input signal, there are two basic types of feedback, that is a positive feedback and negative feedback. So these are basic types of feedback. So here you see what is meant by positive feedback. So here you can say that this is an amplifier, this is input and this is output. So this is a normal amplifier, but through this feedback circuit some part of the output is fed back to the input. So this is feedback circuit, and here you see that it is 180 degree phase shift. So what is positive feedback? In normal amplifier, when input is given like this V in, you know that the output is inverted, that is 180 degree out of phase. Now if this is positive, this signal is negative, and if the same output is directly given to the input without using feedback circuit or network which changes phase, so input will be positive and feedback part will be negative. So that will be called as a negative feedback. But here in this case, this is a negative output, so that negative output through this phase shift network, it is inverted, and again another 180 degree phase shift is introduced and it is made positive. So here now input, phase of input and phase of feedback signal both are same, so they aids in amplification process, they get added, and this is called as a positive feedback. So see, here it is positive feedback is called as a regenerative feedback also. So feedback is in phase with the input signal. So as we saw, if this is an amplifier and input signal is like this, stand up with respect to time, here you can say amplifier of output of the amplifier is basically inverted 180 degree, But here in case of when we talk about positive feedback, this signal is again passed through phase shift network, and it becomes again like input. That means the phase difference between input and feedback part is 0. So this kind of feedback aids the input signal. So we know that this amplifier, every time when we amplify signal, it increases 180 degree phase shift. So this signal and this signal both are 180 degree out of phase, but again this adds 180 degree phase shift, and so total phase shift is now 180 plus 180, 360, and it is nothing but the same signal we get at the input. So feedback circuit introduces 180 degree phase shift. This is a feedback circuit that introduces 180 degrees. It increases the gain of an amplifier. So positive feedback increases the gain of an amplifier, but it introduces increase in distortion and instability. So though gain is increased, but distortion in the output and instability increases due to positive feedback, and positive feedback is necessary in oscillator circuit. So we saw in case of amplifier we always use negative feedback to stabilize the gain and input output relation, but here for oscillating action we need to use positive feedback. So here it is closed loop gain of an amplifier with positive feedback. So here we see this is an amplifier with gain. We know that gain of amplifier AV is nothing but the relation between V out and V in. Okay, so here it is shown Vs is a input signal voltage. Remember that suppose feedback network is absent, then the input voltage, which is a signal voltage, is Vs and output is V out. So gain will be Vs upon V out. But now here it is we are using feedback network. So now to this amplifier, in addition to Vs, which is a signal voltage, feedback voltage will be also there, and so the input Vi, effective input Vi, will be effect due to Vs and feedback part, and that is why Vi will be different than Vs, because of now Vi will be after feedback part, Vi will be Vs plus Vin. So let us Vs be the signal voltage and Vf be the feedback voltage. So now here it is signal voltage is Vs and Vf is feedback voltage. So therefore total input voltage Vi, as shown here it is, so input to an amplifier, to this amplifier, will be the original signal voltage Vs plus the feedback voltage Vf. So that we know. Here it is. But we know that how much part of the output is actually fed back. So remember that. So Vs is signal voltage, Vf is feedback voltage. So feedback part, that means how much voltage is Vf, some part of the output voltage, that is Vo dash. So remember that Vo dash means what? The voltage at the output, some part, that part is decided by factor, beta factor, that is a feedback factor. So beta times output is actually fed back to the input. So this is Vf, and here we see that Vf is equal to beta times Vo dash, and Vi is equal to Vs plus Vf. So here you see that it is equation 1, it is equation 2. So now substituting 1 into 2. So here it is, see, Vf is equal to beta Vo dash. Okay, and here we get the term Vo. So therefore we can say Vi is equal to Vs plus this Vf is equal to beta times Vo dash, that is beta times Vo dash, and that is the third relation which we have got. But we know that Vi dash is equal to Vo dash upon A. Vi dash is equal to Vo dash upon A. This is nothing but gain is equal to output upon input. So A is equal to VO dash upon VI dash. Remember that when feedback network is not there, input is suppose VI, output is V out. But when feedback part is there, input becomes different and output is said to be VO dash. So therefore equation 3 becomes equation 3, see, Vi is equal to Vs plus beta V0, and we know that Vi dash is equal to Vo dash upon A. So here Vi dash can be replaced by this part, and therefore Vo dash upon A is equal to Vs times beta Vo dash. So from this we can say what is Vo dash. So this is at right hand side, it multiplies to the term, and so that becomes A into Vs plus beta Vo dash. So we have got this relation, that is Vo dash O dash is equal to A Vs plus beta Vo dash. So as we have got this term, so Vo dash is equal to, we can say from this Vo dash is equal to, see here it is A into Vs plus A into beta Vo dash. So A into beta Vo dash term is brought to the left, so that is, we can say that is A into Vs plus A beta times Vo dash. So therefore we can say that Vo dash minus A beta Vo dash is equal to A into Vs. So that we have got. So here it is, Vo dash is common, so Vo dash into 1 minus A times beta is equal to A into Vs. So that we have got, but here it is Vo dash, here it is Vs. So Vo dash upon Vs, so from this Vo dash upon Vs is equal to A upon this term 1 minus A beta. But remember that Vs, we saw that is input, and Vo dash is the output, and that is nothing but the gain. So from that, closed loop gain, that is gain with feedback AF. So remember, this is closed loop gain, that is gain with feedback. When feedback is there, output is Vo dash and input is V, that is V total Vi. So now with feedback means input is signal voltage plus feedback voltage, that you remember. So therefore AF, that is a voltage gain, becomes A upon 1 minus A times beta. So here AF is gain with feedback. So here it is A is a gain without feedback. So now what is the relation? So see, A beta, actually 1 minus A beta means this term will be always less than 1. Okay, so 1 minus A beta is always less than 1, and therefore AF is greater than A. So gain with feedback, in case of this positive feedback, gain with feedback is always greater than A, that you should note. So let us consider negative feedback. So see, negative feedback, now the signal feedback is out of the phase with input. So here you see, we get this input signal and output is 180 degree out of phase with input, that we see amplifier. Now the feedback circuit actually 0 phase shift it takes. So that is why whatever signal is fed back to the input is 180 degree out of phase with the input, and so that is why this signal opposes the input signal. So effective signal will, amplitude of effective input will be less than the original signal because of this feedback voltage, which is 180 degree out of phase of input. So this is called as a negative feedback. So here it is, negative feedback is in out of 180-degree phase with the input signal. See, remember that this is amplifier. So if this is the input and say let us consider this is output which is 180-degree out of phase, and when output is fed back through feedback network to the input side, the phase of feedback is again, you see here 180-degree out of phase. That means in negative feedback this signal opposes the input signal. So amplifier introduces 180-degree phase shift. Here it is amplifier which introduces 180-degree phase shift. Here it is, let us consider 0 degree, and here also it is 180-degree as it is, and difference between them is 180-degree. So amplifier feedback circuit introduces 0 phase shift. Amplifier with negative feedback has a self-correcting ability against any change in output voltage caused by a change in environmental conditions, that we already saw in amplifier. It reduces the gain of an amplifier. So remember that gain is equal to VO upon VI, and at this feedback, negative feedback decreases the input, so automatically gain decreases, so it reduces the gain of an amplifier, but it stabilizes the gain and increases the bandwidth in case of amplifier. So this is just related to negative feedback. Now closed loop gain of an amplifier with negative feedback, the same expression as we saw in positive feedback. So this is amplifier. Now here we are considering input voltage is Vi, output is V out, and feedback network gives beta times V out, that is V dash O. So therefore the feedback voltage Vf is equal to beta times V dash O, and input we know that is Vi, but here remember that it is Vi is equal to Vi. Let us consider I means, let us consider this is signal voltage, original signal voltage, plus feedback voltage Vf. But remember that why should we write here positive plus? It is not plus because it is minus in this case, because of there it is a 180-degree phase shift between input and output. So total input is equal to signal voltage minus feedback part, that is a Vf. So here it is V, or we can say the total input Vi is equal to Vif. Here we are not mentioning it is S. Effective input, let us consider Vi minus Vf. So substituting 1 into 2. So again, as we know that Vf is equal to beta Vo dash. So Vi is equal to, as per this, Vi minus beta Vo dash. But we know that Vi dash is equal to Vo dash upon A, that is gain is equal to output upon input. So therefore equation 3 becomes, as we know that Vi dash is equal to Vi minus beta times V0. So putting this value here, Vi dash is equal to Vo dash upon A is equal to this term, and so therefore Vo dash is equal to A times Vi minus beta Vo dash. So from this we can say we got this relation. So Vo dash plus A beta times Vo dash is equal to AVI, and from this relation we get Vo dash upon Vi is equal to A upon 1 plus A beta. So where this is nothing but the closed loop gain with the feedback. So therefore AF is equal to A upon 1 plus A beta. Now remember that 1 plus A beta term is added into A, so that is why this term is always greater than 1. So therefore always is AF is always less than 1, always less than A. This is the case of negative feedback. So negative feedback, it decreases harmonic or non-linear distortion and reduces the effect of input offset voltage at the output, as well as it reduces the gain of an amplifier that we already saw. So let us consider different types of feedback is there. So remember that if this is a network, so this is input side and here it is output side. Now we are going to think that if this is feedback network, so it can be, that means feedback is given to the input side with different types of combinations. So here first is voltage series feedback, that means voltage taken from output is fed in series at the input. Second is voltage shunt feedback, that means output voltage which is fed is in parallel. Similarly, we can have a current series feedback and current shunt feedback. So there are 4 types of feedback there. So here it is voltage series feedback. So see, here it is in circuit, you can see. So these are input terminals. Okay, so input is given and we get output, and the load resistance RL is connected across the output terminals. So here in voltage series feedback, the output voltage is given to the feedback network, but look carefully that the voltage which is fed back, it is not connected to both the terminals but to one terminal only in series, and so the fraction of output voltage is fed back in series with the input voltage. Feedback network is in parallel with the output. So look here, output resistance, this is RL, and both end of RL are connected to both end of feedback network. So RL, that is output, and feedback network are parallel. So in this case input resistance increases and the output resistance decreases. So this is one important characteristics of this kind of feedback type. So voltage gain and harmonic distortion decreases. So this is voltage series feedback. Second one is voltage shunt feedback. The fraction of output voltage is fed back in parallel with the input voltage. See, as we saw in previous case, the output is taken from both the terminals, but now the feedback portion is not in series with a single terminal, but both terminals are connected to both the input terminals. So this is called as a shunt or parallel feedback. The fraction of output voltage is fed back in parallel with the input voltage. The feedback network is in parallel with both the input and output. See, here it is feedback network. Here input side both are parallel, output side parallel and input side parallel. So both input and output resistance decreases as feedback network is in parallel with input and output. We know that when two resistors are in parallel, effective resistance decreases. So both the input and output resistance decreases, and voltage gain and harmonic distortion decreases, but bandwidth increases in case of voltage shunt feedback. So next one is current series feedback. So here you see, here in current series feedback you can see that the output current feeds the proportional output voltage back into the input series. See, here it is. Now instead of taking voltage or potential across load resistance, the current is flowing to load resistance, and that current is fed back through the feedback network. So the output current feeds the proportional output voltage back to the input in series. Feedback network is in parallel with the output. That feedback network is in series with the output. Here we see, and feedback, the input impedance and output impedance can be increased as the feedback resistance of feedback network is in series with the output as well as input. The corresponding impedance increases. So voltage gain, noise and harmonic distortion decreases, and bandwidth increases. So this is a specific characteristics of this current series feedback. Current shunt feedback. See, here it is, the current is taken which is in series, but it is fed back in shunt parallel to the input. So the output current feeds the proportional output voltage back to the input in parallel, that we saw. So feedback network is in parallel with the input. Now here it is, see, this feedback network is in series with the output, but this feedback network is in parallel with the input. So input resistance decreases and output resistance or impedance increases. So here it is, voltage gain, noise and harmonic distortion decreases in case of current shunt feedback, but the bandwidth increases. So these are basically 4 types of feedback related to current and voltage, series and shunt combination. So now let us consider oscillator. That is nothing but the amplifier with positive feedback. So remember what is oscillator. Suppose let us consider a pendulum and it is oscillating. So once it is oscillating, we know that after some time its amplitude decreases, that is energy is reduced and it comes to end. So this way oscillation is there. Initially amplitude is large, then in course of time it decreases, again decreases and it decreases. So in order to have the output sustained, every time we need to feed the extra energy to the input such that every time the amplitude of the oscillation will remain constant and the oscillations will be sustained. So no damping is there. So in case if this is an amplifier to which input is given, and if this is an output, so input, so if we provide positive feedback, this is feedback to the input, we'll get the sustained oscillations, that is basically an oscillator. But remember the important thing to be noted in oscillator: the circuit which converts DC energy into AC energy at high frequency. That means if this is an oscillator, it does not need input. That is most important thing. So basically it is a amplifier circuit with positive feedback, okay, and no input is there. Then question is that how output we are getting the oscillations. So the oscillations, that is whatever oscillations we get due to this positive DC voltage. So now oscillator is a circuit which gives us oscillation, that is output is AC, this is DC. So DC is converted into AC using oscillator with the help of positive feedback to which there is no input at all. So oscillator does not require an external signal either to start or maintain energy conversion process. That means this oscillator circuit does not require external input. It can automatically convert this DC energy into AC signal. It produces an output signal which is an AC. So this is a block diagram of an oscillator. Here you see this is an oscillator in which DC energy is converted into AC. So Barkhausen criteria, let us consider for an amplifier with positive feedback. So let us consider this is an amplifier which has a positive feedback. So we know that gain of an amplifier AV is a relation between V out upon V in. Okay, but what is happening actually, we are giving some part of output to the input. That means input is changed, concerning the output is also modified, and that is why we can say the VO dash, when feedback is connected, output will be VO dash divided by V in, or we know that already we saw, that is gain of amplifier with feedback, the relation is A upon 1 minus beta A, that we already saw, that is closed loop gain A dash after providing feedback. In case of positive feedback, that is A dash is equal to A upon 1 minus beta A. So A is open loop gain, A dash is closed loop gain, and beta is feedback factor. So this factor is beta. Now to start oscillations, a quick trigger signal is required given to the circuit. Once oscillation started, no external signal source is needed, and in case of our phase shift oscillator, Wien bridge oscillator, the input signal is taken from the circuit itself. So here it is, Bar-Khousat's criteria we are discussing. For an amplifier with positive feedback, voltage gain is A. So that is AV is equal to V dash upon V in, or this. So since no external source is needed, remember that note, as no external source is needed, the gain of amplifier becomes infinite. So if external source is not taken, that means V in is absent. So when V in is absent means what? V in is 0, and if it is 0, so AV is equal to VO dash upon 0, that turns to be infinite. And it is possible, but that gain A dash is equal to A upon 1 minus beta. So if this gain is infinite, it is possible only when 1 minus beta A is equal to 0, or the condition for oscillations, that is a Bar-Khousat's criteria, that is in designing oscillator we should know that beta times A is exactly equal to A1, and this is called as a Bar-Khousat's criteria regarding to positive feedback in oscillator. So here now we saw, important thing is that this is an amplifier. If we use amplifier to which DC energy is given, if we use positive feedback, it acts as a oscillator. So now there are types of oscillator, that is a sinusoidal oscillator. It generates sinusoidal oscillations of desired frequency, and the output is sinusoidal wave, that you remember. And other type of oscillator, that is a non-sinusoidal wave, it generates waveforms other than sinusoidal waveforms such as square wave, rectangular wave, sawtooth wave, and other pulse shaped waveforms. So let us consider an example of an oscillator using operational amplifier, that is a phase shift oscillator we are going to consider. See, for an oscillator to sustain its oscillations indefinitely, sufficient feedback of the correct phase, that is positive feedback, must be provided along with the voltage gain of an amplifier being used. So see, this is an amplifier with certain voltage gain. Let us consider. So we know that if suppose this is an input signal, in case of amplifier we know that output is inverted, that is 180 degree out of phase. But to convert this amplifier into oscillator, we need to provide some feedback. Okay, so that feedback must be a positive feedback. Positive feedback means what? That the output, which is actually inverted part of input, but once it passes through feedback network, it must be in a phase of the input. So both are same, that is called as a positive feedback, and that is given. So here sufficient feedback of the correct phase, that is positive, must be provided along with the voltage gain of an amplifier being used, so that the oscillations will be maintained. Now let us consider this signal is, we know that it is, I have shown, that is this is this kind of signal which is 180 degree out of phase in. Now we have to convert this signal this way, that means we want phase shift of 180 degree. So whatever phase shift network which we are using for positive feedback, how it works. So in case of phase shift oscillator, we are going to use RC network for phase shift. So here see, if we consider this kind of RC network and input signal is given, suppose let us we are giving the input signal to this side. So whenever we take output, the output is 90 degree, ideally 90 degree out of phase of input. That means remember that one RC network can shift the phase by 90 degrees. So how exactly it is happening? See, the phase shift occurs between input and output of the RC network. One RC network gives phase shift of 90 degree. So how here city? One, if we connect capacitor in the circuit, its capacitive reactance, we know that XC is equal to 1 upon 2 pi FC. So frequency is most important component and value of capacitor. And the resistance in the circuit R is equal to R. So now total reactance of this network in the AC circuit is called as a impedance, and that impedance Z is equal to under root resistance square plus capacitive reactance square. So from this we can say the phase difference phi is equal to tan inverse XC upon R. So this circuit, we know the value of C. From C we can find out XC, and we know the value of resistance R. So by putting those value, we can find out how much phase shift it can generate. So in case of RC network, ideally we get 90 degree phase shift, but practically we do not get exactly 90 degree. And here whenever we are using phase shift network here, so that phase shift network should change the phase by 180 degree. Okay, but we know that ideally it gives 90 degree, but using two networks, if we try to get 180 degree phase shift, practically it becomes complicated. So we select 3 RC network. See here it is phase shift oscillator. So here it is first network RC, this is another RC, and this is another RC. And now we need to select the value of R and C such that one network will create a phase shift of 60 degree. So 60 plus 60 plus 60, total 180 degree phase shift will be there. So here figure is shown. Remember that here we have the voltage source, that is plus VCC and minus VCC. This is an operational amplifier. This resistance RF and this R1 controls the gain of an amplifier. So this is nothing but the amplifier circuit which has certain gain, that is we know that is minus RF upon R1. So that output voltage will be generated, but that output voltage will be fed back to this phase shift network, and this phase shift network will introduce 180 degree phase shift. So automatically the signal which is fed to input will be in phase with the input. That means there will be a zero phase shift in the feedback, and that is called as a positive feedback, and it will sustain its oscillation. So in this circuit, the frequency of phase shift F0 is given by F is equal to F0 is equal to 1 upon 2 pi times under root 6 RC, where R is resistance and C is capacitance. So this way remember it's working. This is an amplifier. Once amplifier starts, we get the output. So that output signal is given to the RC network. So the complete network shifts the phase by 180 degree, and the input becomes a positive feedback, and that is again feedback to the amplifier, and this way the continuous oscillations we are getting. Okay, so here if you want to change the phase, we have to change the value of R and C, that you remember. And here important thing, when this is an oscillator circuit, you observe that as in case of amplifier we used to use here V in, that is input voltage, so no input voltage is required. Internally when the circuit is turned on, internally it gets a trigger and we get some output voltage and oscillation starts. The frequency of oscillation depends on this, that is FO is equal to 1 upon 2 pi root 6 RC. So this is phase shift oscillator using operational amplifier. Okay, thank you very much. Bye.